This video validates the October 1st, 2019 article, CCPA and GDPR, another compliance breakthrough. Encrypt and update your RDBMS in real time as you run DPIA Discoveries. We'll be showing the direct discovery for emails and, when found, their immediate encryption and update back to their originating file, column, and row. This is shown for MySQL and for Oracle. Also, an example of a new schema and file with the emails encrypted are created for MySQL. This is shown for those companies that have terabytes to petabytes of data. We'll use these tables architected with change data capture techniques to update their files with the necessary encryption to become and stay privacy data regulatory compliant. Here, we see in the mock data file, email column in the MySQL database. The data is not encrypted at this time. Now, we establish the Spark JDBC connection to the MySQL database and test the connection. All is fine. Now, we select the table or tables we want to run personal information discovery on, with the option to also encrypt this information immediately when it's found. Then, within the dropdown, we can request only metadata for later use, writing back to the database, or AWS, S3, or Hadoop, and also click a checkbox to update live to the production data for the smaller files. Now we select one or many patterns or values to discover for, confirm we have the right key, and can optionally modify the Spark fetch size to speed up the processing of Spark. Then we run the discovery or DPIA process. Here we see the parameters this job is using to run the discovery. Now, as we refresh the original production MySQL mock data file, we can see that only the email column has been changed and updated. The emails, as per the user's request, was discovered and then encrypted to meet one of the regulatory compliances. Now, as we open and view the job's metadata, we see what column and how many rows were affected by becoming encrypted. Our comprehensive collaborative metadata catalogs allows the user to select by the type of run, the date span for this metadata, the patterns of regulatory compliance searched for, and the individual or collective values searched for, in the case of a citizen's right of erasure. This metadata then becomes available for download in a reusable and shareable CSV file in Excel. As you can see, we are viewing earlier activities as well as the recent runs. We are now setting up to run another discovery, this time searching for IP addresses. Also, instead of updating the mock data table in real time, we are establishing a new schema to write the table and its new results into. This is also being done against MySQL. This process is used when you're discovering against larger files and will update your production RDBMS at a later time, using what is referred to as change data capture or file comparisons. This file could have been suppressed from being written and only the metadata written, or the file could have been written to Amazon S3, Hadoop's HDFS, HBase, and soon MongoDB, and many others. Here, we see in the new schema name and mock table, the IP address is now encrypted, as we requested it to be in the discovery encryption process run. As we now look over at the originating production schema for the mock data file, we see that the IP address is still unencrypted, as we did not select for real-time update to occur. Now, as we open and view the IP address, jobs metadata, we see what column and how many rows were affected by becoming encrypted. We're looking at the sample table in the Oracle database now. We see that the email address is not encrypted at this time. Now we establish the connection to the Oracle database and confirm it successfully connects. We select the sample table we just looked at. We select to write the data back to the Oracle database and select to update the sample file in the production schema. We select to discover for emails, and again, we'll encrypt and live update the Oracle sample file for emails if found. Now we run the process. As we review the Oracle sample file and its email column, we now see emails are encrypted as we requested them to be. Now as we open and view the Oracle email jobs metadata, we see what column and how many rows were affected by becoming encrypted.
From this point to the closing statement of this video, you will see additional video of the following RDBMS databases completing the personal identification and discovery process and real-time encryption and update to the tables and columns where emails were found. The databases, in addition to the MySQL and Oracle already presented in this video, are Teradata, PostgreSQL, Microsoft SQL Server, and IBM's DB2. Of course, we have offered Big Data Hadoop HDFS for a few years already.
This video will back our powerful claims of yesterday's post that stated CCPA and GDPR, another compliance breakthrough. Encrypt and update your RDBMS in real time as you run DPIA Discoveries. We cure the SME issues of small IT staffs, budgets, and minimal ETL and data governance technology to accomplish compliance. We have inventively integrated our RDBMS Direct Update Capabilities with the latest Apache Spark's capabilities to achieve the speed, scalability, and distributed power of Spark's memory processing required for timely and accurate compliance. BDR has the scalability to process data in motion, such as IoT and other live feeds, that offer real-time encryption and updates to RDBMS files during ingestion, just as we have previously for non-RDBMS. WordPress, e-commerce, and websites. BDR overcomes compliance obstacles with a simple port redirect to our BDR proxy server on AWS, AMI, or our solutions on the cloud or server of your choice. Arrange a live demo and even request to have us point to your data live for the demo from our AWS servers. BDR and BDR's proxy available now for MySQL, MongoDB month end, and Oracle soon thereafter, and others before year end. Go to bigdatarevealed.com and in contacts request a demo or trial of the BDR Compliance app and BDR Proxy Server. Thank you for watching this video and taking interest in BDR.